There are many different types of galaxies. Not all of them are spiral, not all of them look the same. In 1925, Edwin Hubble created a system for classifying and organizing these different galaxies. Now, first off, there are two major types, and the two major types of galaxies are spirals and ellipticals. Spirals, as you can imagine, have this pinwheel sort of structure, and ellipticals are kind of big fuzzy balls. They look just like a big fuzzy ball of star clusters out there. Since Hubble started out with his two primary types back in the 1920s, modern astronomers actually have 6 different types of galaxies that exist. There are spirals. Then there are things that are called barred spirals. Barred spirals, instead of the center being round, the center is a little bit more oblong. There are some galaxies that are called irregulars because they are the clusters of matter that have the mass to be a galaxy, but it does not have an organized uniform structure. There are actually a couple of my favorites. There is one type of galaxy that is referred to as a peculiar, and peculiar galaxies sort of look like they're combinations of galaxies. They're in the process of forming, but they're not there yet. Ellipticals, that are these round structures, and then lenticulars. Lenticulars are very organized. Ellipticals, very specific shape. Why lenticular? They are nice and lens shaped, not as round as ellipticals. There are a collection of videos, each one's about 3 minutes, that I'm going to ask you to watch when we're done talking about these. Each one gives some great explanation and a lot of great visuals on these types of galaxies. So when Hubble was trying to organize all these different types, he created a system that today we refer to as Hubble's tuning fork. A tuning fork is a little gizmo that has 2 arms that kind of go like this, that a person will clank and it will vibrate and it'll make a very specific noise. The Hubble tuning fork just refers to the shape of his diagram, that there is a handle kind of shape and 2 separate tongs or arms. When Hubble created this tuning fork shape, he used this to help differentiate the variety of different types of galaxies. Here's what this shape does not tell us. It does not go through the direction or age. It doesn't say that galaxies start here and evolve and go there. Hubble was hoping that that's what would occur, but with more evidence, we indicate that nope, that's not it. So it is just something that's used to help organize all of the different galaxies that are out there, but it does not tell us stages or steps of galaxy evolution, and we will talk about that later. So we're going to start with talking about the upper fork of Hubble's tuning fork, and these contain spirals. There are 2 or 3 letter abbreviations for types of galaxies, and the upper fork of the tuning fork contains these spirals. Spirals are abbreviated with a capital S. And then how far along they are on that fork then there is a second letter, A, B, C, and some actually talk about an S, D. So it depends, honestly. I've seen both. Depends on what book you're reading or what website you're on. The SAs closest to the center have a very large central bulge, very, very tightly wound arms. And as you go from the SAs to the Bs to the Cs, the central bulge has a tendency to get smaller, from big to small, small, small. And it also, the arms themselves get more loosely wound. As you go from the center of the fork to the ends of the fork, I always figure it's sort of like a rose opening. The center is more like that tightly wound, tight center. And as the rose sort of opens, you end up with a larger, looser structure, and the center is actually smaller instead of a dense center. So that's the S's. There's more gas and more active star formation in the far SCs and SDs than there are in the closer in SAs. The next type of galaxy are barred spirals. Barred because in the center of the galaxy, instead of it being a round shape, there is a shape that looks like a bar. These are abbreviated SB for barred spirals, and then again there is a letter behind it to indicate if they're near the center or the outside edge. Again, S near the SBA, SBB, and SBC. There's a very subtle difference between the barred spirals and the spirals. Spirals are going to have a rounder shape, and barred spirals, there is a definite bar kind of shape. So here are a couple different barred spirals. There's one. Here there is a very not terribly opaque, dusty barred spiral section right there. Our Milky Way galaxy is not a spiral galaxy. It is actually a barred spiral galaxy. We are kind of halfway between an SBB and an SBC. And again, tight, big central bulge, tightly wound, and everything gets loosened up as you go towards the outside edge of that tuning fork. This is another really nice picture of these galaxies using real astronomical observations. So SBA's nice and round. You can see some spiraling there, but it's quite tight, like a rose that's tightly wound. As that kind of opens up a little bit, you end up with the spirals are kind of opening, and the central bulge is maybe not as big. And then lastly, you're talking about a spiral galaxy, large, loose, open arms. The SBs, the barred spirals, same thing, very tight center, not very distinct arms around it. By the time you get to an SBB, a little bit more distinction in those arms, and an SBC, big, loose, looping, rotating arms. Ellipticals. Remember, there are 6 types: spirals, barred spirals, and another one is elliptical. Now, elliptical galaxies have no disk, no galactic disk, and no arms. There's not a lot of gas and not a lot of dust in elliptical galaxies. They look like big globs of light out in space, but they're really made of millions and millions of stars, which is amazing. They have very little rotation, and they also consist almost entirely of old stars. Do you remember which color is an indication of coolness? All right, the cool colors in astronomy is red. So red indicates cold, and stars that are older and dying and kind of going out, they're losing their light. A lot of elliptical galaxies are going to be kind of yellowy orange, and that yellow orangeness is an indication that these are old, cold stars. Elliptical galaxies also look like just the bulge of a spiral without the spiral arms around them. Now, on Hubble's tuning fork, elliptical galaxies are on the handle, and they have letters E for elliptical, and then they go E0, E3, E5, E7, as you go from very, very, very round to a situation where they are very oval. When an astronomer categorizes one of these elliptical galaxies, they are doing it based on just appearance. How does it look to us on Earth? The challenge is, because we cannot see them from another angle, they're so big and so far away, we haven't gotten to that situation yet. We base this classification just on how it looks. And I like this combination of pictures because if you look at an egg from the side, it looks kind of oval. if you look at the same egg from the end, and yeah, I got this off of some Easter egg decorating website, it looks very, very round. So you could have two identical galaxies. One we could call an E7 and one we could call an EO. What's the difference? Our point of view. Are we looking at this galaxy end on, or are we looking at the galaxy from the side? So this is just based on observation. How does it look through a telescope? Most elliptical galaxies are, and this is one of the challenges with elliptical galaxies, there are two major types of ellipticals. There are many elliptical galaxies that are dwarf galaxies. Around Andromeda, this is our neighbor Andromeda, there are some dwarf galaxies, and these dwarf elliptical galaxies are small, a few million solar masses, which is still very, very, very big, and they are companions to much larger galaxies. So those are dwarf ellipticals. A small fraction of ellipticals are huge, 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 mega huge. These are, we believe, the result of spiral galaxies colliding. So you've got two spiral galaxies, and the spiral galaxies have actually collided, and you have these massive black holes at the center that give rise to these elliptical galaxies. So the fact that there can be two different kinds of ellipticals is also kind of confusing. Fourth kind of galaxy is lenticular. Now, lenticular, again, looks like a lens. It looks like a lens. There is, the disk is like a spiral, so there is a disk associated with it like a spiral, but there's no arms. There's no rotational separation of this disk into arms. Very little gas, very little dust in a lenticular galaxy. And these are referred to as SOs, and they happen to be located right at the apex of Hubble's tuning fork. The last two are the wacky ones, and these are the irregulars and the peculiars. So irregulars have no regular shape. In the southern hemisphere, you can observe these two, which are companions to Andromeda, and they're in our local galaxy group. And these are the Large and Small Magellanic Clouds. The Large and Small Magellanic Clouds are perfect examples of irregular galaxies. They have not evolved into having nice shapes like ellipticals or nice spiral shapes like normal spirals or barred spirals. Where on Hubble's tuning fork do irregulars go? Usually they are placed kind of between the two forks, and there are many of them out there. These are just galaxies that haven't gotten to one of the other shapes yet. Typically also, these are young areas, lots of star formation, lots of infrared, lots of heat being generated because, and you can tell by the color, what color is dominant right here? Yeah, lots and lots of blue. And blue stars are hot and young. So that's one of the things that we believe irregular galaxies are just young clusters. If something doesn't fit into any of the other categories, it gets thrown in the peculiar class. Again, this is based on just what we see through a telescope. So peculiars can be wacky combos of everything else. They often look roughly spiral or roughly elliptical, and then they've got some sort of wacky abnormality. Here is a ringed galaxy. So it sort of looks like a elliptical in the center, and then you've got a ring of debris around it. Did not develop into arms, but it developed into rings. That's kind of wacky. Here's one that looks like an elliptical in the center, and instead of arms, again, it has a ring out there. This looks like very much like there are two galaxies in the process of merging. And so here's a galactic center, here's a galactic center, and those spiral arms, yeah, boy, you got a lot of wackiness going on here. Kind of looks like this was spiral at one point in time, or a barred spiral. This guy was probably spiral, and you get that interaction. Same thing here. So peculiars often are interacting galaxies in the process of changing from one form into another form. Couple videos I'm going to ask you to watch at the end of this section will do a nice job of explaining and filling in the gaps that I may have missed. And then when we come back, we are going to start talking about galaxy evolution. How do they change from one form into another? See you then.